Hello, my name is Eva Ahmed, and today I'll be talking about Lab 1 charged tapes. The purpose of this lab was to become familiar with the concept of charge and excess charge while learning how to design experiments and make and simplify assumptions. This lab had the objective to quantify and observe the interaction between charged objects while seeking to determine the amount of excess charge on an everyday household object. To complete this lab, we needed to understand a few key concepts. The first of which is Coulomb's law, which quantifies the amount of force between two electrically charged objects as seen as the diagram below. The second of which is the electric field formula. This explains how the field of an electrically charged particle and the forces they exert interact. The third is the universal law of gravity, which describes mutual attraction between massed objects and is described in the formula as seen below. The final one is Newton's second law, which describes how an acceleration of an object depends on the mass and force applied. To complete this experiment, we had to follow the experimental procedure as detailed in the lab on Canvas. The first part of the experiment dealt with charging the tape. We did this by using a 20 centimeter piece of tape with the handle folded down to create a base tape. Then we added another 20 centimeter U-tape on top of the base tape and pulled this U-tape off in order to charge the tape. We then tested the charge by applying the U-tape to the edge of a surface and bringing our hand close to the tape. If the tape was correctly charged, it would move towards the hand. Note that if the tape did not move towards the hand, it was important to remake the tape and start over. To finish testing the charge, we then made two other U-tapes and observed the interactions between the two. Then we observed the interaction between the U-tape and a neutral object. Finally, to test the charge, we observed the interaction between the U-tape and a charged pen. This pen was charged by rubbing the pen in the hair. The final part of the experiment was dealing with determining excess charge on the tape. We placed two charged tapes near one another and observed the interactions in water, and used force to determine the amount of charge on one tape. This is demonstrated in the diagram seen here. Note that we consider tape B the system and tape A the surroundings when completing our calculations with this diagram, and we have to record the distances between the tapes. Another note, we have to assume each U-tape has the same net charge and all charges are treated as a point charge with an equal distribution of charge across the tape. This is an important assumption to make to complete the experiment. Here are some observations I made while completing this experiment. Holding the two charged U-tapes near one another would cause them to repel due to their like charges. Positively charged objects would repel other positively charged objects. The positively charged U-tape was attracted to the negatively charged pen. However, if the tape was negatively charged, it would repel the pen, and if the tape was neutral, it would also be attracted to the pen. In the final part of the experiment, when we placed tape A and tape B near one another in water, tape B began to float when tape A was 2.2 centimeters away. Another part of this experiment dealt with creating a computational model of our scenario. Here's some code that I created in order to computationally model the charged tapes experiment. Here's the output of my code, which was used to determine the charge on the tape, electron deficit of the tape B, and the amount of atoms on the tape, as well as the ratio of deficient electrons to atoms. It also helped me to compute the force due to gravity acting on the tape. As you can see here, the charge of the tape was calculated to be 1.0266 to the 10 to the negative e coulombs, while the electron deficit is seen here for tape B. Here's some calculations I did to back up my computational model. Once again, I calculated the force of gravity on the U-tape, the fraction of atoms that gave up electrons in terms of the ratio of deficient electrons to atoms and the number of atoms on the sticky side of the tape, as well as the charge of the U-tape and number of deficient electrons. Here's some final questions that I had to answer as part of completing the lab. What if electrons had a positive charge and the protons had a negative charge? What would change about the observations you made with your tapes and other charged objects? Nothing would change with my observations. The charges would still be transferred when the tapes are pulled off one another. The charged tapes would still interact with the neutrally charged hand, and in addition, the transfer of charges would still cause one of the tapes to float as like charges repel. Finally, why is it important to handle the charged tapes as little as possible? What happens when charged tapes come into contact with their hands or other objects? Since the tapes that interact with other objects can transfer charges due to the electron deficit in the tape. This can adversely affect the charge of the tape, such as reducing it in charge. This is why it can be dangerous if the charged tapes come into contact with hands or other objects. This concludes Lab 1.